Chapter 4 takes a totally different direction than what we've been doing. Now we're going to get into probabilities. And there are probabilities of those discrete random variables, which means things you could count, like number of faces on a die when you roll a die, or a pair of dice when you flip a coin, how many heads or tails can you get? So something that you could count, countable. And chapter 5 and on, or 6 and on, I believe they take on continuous, which is a bit more challenging. So for now, we're going to try to set a probability and the theory of probability, something we're going to use throughout the course. So basic concepts of probability. We have definition of a probability. Probability is a numerical measure of the likelihood that a special event will occur. So statistics, notice statistics, I can find information about my sample I clicked a button by mistake. About my sample, and I would use that to make a prediction about my entire population. This is what statistics does. I take a sample of 3 classes in Pasadena, take their probability, and I generalize for all of these courses offered in Pasadena. I take 50 students from Mount SAC, and I generalize for all 45,000 students. So I collect information about my sample, my small sample, and I make a prediction about a lot, basically the population. Probability works the other way around. If you look at the probability, this is what we're going to be doing now. Probability, I know information about my population. What I do, I predict information or prediction about likelihood. Missed an E in there. Crap, how did I put that? The likelihood of getting this sample. So, it's kind of a reverse order. Prediction or predict information, it's the same thing. So, terminology. We have to set 3 things. An event is any collection of results or outcomes of a procedure. An event would be like an even face when rolling a die. And if we all remember, I thought, here, I could draw one really quick. If you're unfamiliar with a die looks like this, where you have one side with a 1, one side with a 2, one side with a 3, 4, and 5. So an event would be an even face. When you roll a die, what would be the event that you get an even number? A simple event is an event that cannot be broken into simpler events. something like getting a 3 when you roll a die. So 3, well, there's only one way of getting a 3. That's a simple event. Not a simple event would be like the even, getting an even face. 2 is even, 4 is even, and 6 is even. Since you could break that into 3 different ways of getting there, then that's no longer a simple event. That's compound event. So a simple event is an event that cannot be broken further. The sample space for a procedure consists of all possible simple events, specifically simple events. So letters that are used in this book, P is always reserved for probability. Probability of an event, and events are capitalized, is written with parentheses around the event. So we have an example. Now we're going to talk about probability and definition. For now, we're just going to get into an example just to get a feel of how this works. A probability experiment consists of rolling a die, rolling a 6-sided fair die. Determine the sample space. What are all the possible things that could happen? I could get a 1, I could get a 2, I could get a 3, I could get a 4, I could get a 5, I can get a 6. That's it. What's the probability of getting a 5? Probability of getting a 5, again, we're going to define this in the next page and the coming sections. The denominator will be the total possible outcomes, and that's all of those. So the denominator of a probability is always, the denominator of a probability of an event would be always all the possible choices. There are 6 things that could happen. And the top is always, how many ways can you satisfy this? Well, there's only one of them. There's only one way of getting that 6. Now, on a test, you leave it in decimal, you leave it in a fraction, I can care less. It's all the same. How about here? If I say, what is the probability of getting an even? Well, you roll a die once, there are 6 choices. But, how many of those are even? Well, even, that's even, that's even, and that's even. So we have 3 ways of that happening. That would be 1/2 or 50%. Now, you could throw those in a calculator. A decimal I'll accept, and a percentage I'll accept. That's all fine. There's nothing wrong with any of those. You could also, if you wish, write this in decimal, or, and we're going to get those out of the way. So on a test, this is a fine answer. If I take 1 divided by 6, I can give the decimal, because the back of the book does that back and forth, and I want to make sure that you're not thrown off by that. 1 divided by 6 is 0.166, which is 16.67%. So, any of these answers I'll accept. Important things to know about a probability. So, important notes. For any probability of an event, the probability is always between 0%, 1 stands for 100%. Those are in decimals. The probability of an impossible event is 0. If I was to say in the problem above, what's the probability of rolling an 11? Well, there are 6 choices. None of them are 11. So that's impossible to happen. The probability of an event that is certain to occur is 1. What's the probability of getting an integer? Again, same example. There are 6 possibilities. Well, let's see. 1 is an integer, 2 is an integer, 3 is an integer, 4 is an integer, 5 is an integer, and 6 is an integer. That's 1, which means 100%. You're guaranteed that's going to happen. I could use a different example, but you're not going to like it. What's the probability of dying? 100%. We're gonna die up till now, unless somebody figures out something else. That's what it is. If necessary, round probability to 3 significant digits, something we're gonna be playing with, and I'll point this out as we do examples. Now, up till now, we assume, so in statistics, we assume an event is unlikely if it's over 2 standard deviations or below 2 standard deviations from the mean. Now, in probability, this rule we're going to carry with us for a while, and it will change later on, but the problem will be specific. But if they say nothing, an unusual event in probability is an event that has a low probability. Typically, an event with less than 5% is considered unusual, but it depends on the problem. So, if they don't say anything, they give you any problem and they say, is this event unusual? If we're using probability, you find the probability. If it's less than 5%, you know what? You say that that's unlikely to happen. That's unusual. Normally, these things don't happen. Keep in mind, probability has one weakness. A probability makes the assumption that everything happened due to chance, nothing else. And that's why, if it only happened 5% of the time, we say, you know what? Well, it doesn't make sense for you to say it's happening due to chance and it happens less than 5%. That's really where we're going to do the cutoff for these probabilities. So statistics, above 2 standard deviations, below 2 standard deviations is considered unusual. But here, in probability, we assume less than 5% is unusual. So there are 3 approaches to probability. We're going to focus on the most typical. Relative frequency probability, this is what we just did based on data. And the formula for that, the probability of event A would be, denominator is the total number of trials, and the top would be the frequency of event A. So this is what we just did. An example of that would be right there. Relative frequency, 200 million people are affected each year by malaria, a disease carried by mosquitoes. 600,000 of those people die. That's a lot of people. What's the probability that someone affected by malaria die? The probability that somebody dies from malaria, the denominator is 600 million. That's a big number. I'm sorry, 200 million. Same thing, only off by 400 million. And 600,000 is the frequency, right? If I put this in my calculator, .003, which is not 3%, you guys, 0.3%. You know what? I should use a thinner pen here. So that is a relative frequency probability. A classical probability would be something like based on hypothesis, something that you know. Equally likely outcomes. The formula for that, the probability of event A would be, the denominator is the total possible outcomes, and the top will be the possible outcomes of A. An example of that would be, well, right there. when two children are born, what is the probability that they're both the same gender? Well, the sample space, two children are born, I could get a boy, first a boy, second a boy. I could get a boy first, then a girl next. I could get a girl first, then a boy next. Or I could get two girls. That's all the possible ways this could happen. The probability that both of the children have the same gender, well, there's 1, 2, 3, there are 4 total possible outcomes. And how many ways can you satisfy both have the same gender? There's only 2 of those, so that's 1/2 or 50%. Again, you can leave the answer in fraction out of mind. Now, this subjective probability is not the most typical. The probability of an event A is found by simply guessing or estimating its value based on the knowledge of relative events. And here's an example, subjective. What is the probability that the next dollar bill you spend was previously spent by Beyonce? Well, unlikely. What are the chances of you winning the lottery? Unlikely, but people win it. And now we have another example. This is more like applying what you're going to see on the homework. A bag has 1 red, 1 blue, 1 yellow, 1 orange, 1 purple marble. That means we have 5 altogether. The table below shows the results of choosing a marble out of the bag and replacing it each trial. Give answers as decimals and percentages. Okay, very good. So, outcome of a trial, there's the red, blue. What they did this 100 trials. They tried it 100 times. They put their hand in, take a marble, look at it, record it, and put it back in. And this is what they got. And then they did it 600 times. So, find a relative frequency probability of drawing yellow or orange for 100 trials. 100 trials is right there. What is the probability of getting a yellow or O for orange? There are 100 trials. And how many ways can you satisfy this? Wouldn't those 18 will do and those 17 will do? If you have a choice in statistics, you always add. If you don't have a choice, you multiply. So always remember that. So that's 35 over 100. If I throw this in my calculator, that's 0.35. That's the decimal answer, or 35%. So they wanted the answer in decimal, and they wanted the answer as a percentage, and we gave both. The next example says, find the relative frequency probability of drawing a marble that is not red. In the 100 trial, the probability of anything that is not red. Well, there's 100, right? How many are not red? Well, red is 33. So wouldn't you say, 2 ways of doing this. Either you say not red would be 100 minus 33, which is 67. Or you say not red, well, add anything that's not red, 24 plus 18 plus 17 plus 8, which is 67. And you get that number. So either way, it doesn't matter. And you could do this as a probability automatically. And you could just do this over 100 or this over 100. Unplug it, let the calculator do the work. You know, you could just use parentheses. The first case, you will take parentheses 24 plus 18 plus 17 plus 8 divided by 100. One shot. Or you could say the 100 minus 33 divided by 100. make sure to use parentheses properly. There it is. So that is 0.67 or 67% chance of that happening. How about C? Find the relative frequency probability of drawing a blue. Probability of a blue. There are 100. How many of those are blue? 24. So that's either 0.24 in decimal form or 24% in percentage form. And if I run, find the relative frequency of drawing a blue in the 600 trial. In the 600 trial, that's 121. What's 121 divided by 600? That's 0.201666. So I'm going to say 0.013 decimals, they said. I'm going to say 0.202 or 20.2%. And now they ask, hey, can you tell us what is the classical probability? Remember, there was one of each. Initially, there was 1, 1, 1, 1, 1, 5 of them. Well, probability of getting a blue in the classical is really, out of 5, there's 1. That's 0.2 or 20%. Do you notice when he did the trial 100, 20% of one, those should be 20 each, but do you notice how odd this number was? This is really 8%, this is 17%, this is 18%, 24 and 33. Do you notice what happened when he did the 600 trials? 600, 20% of 600 is 120. Do you notice the red came out about 120, blue very close, yellow very close, orange very close, and do you see that purple got very close? So for probability to work, we should repeat it a lot of times. As a procedure is repeated again and again, a lot of times, the relative frequency probability of an event tend to approach the actual. The actual is 20%. If I was to do this instead of 600, 6,000 times, these would be very close to 20%, almost identical. And a very important topic that we're going to be using in the next section and on, a complement. Denoted by, so if you have event A, the complement of A, this class puts a dash on top, other statistics book put a C on top, consists of all outcomes in which the event does not occur. So, not the opposite, but it's not what you're looking at. So, if event A is getting the evens by rolling a die, the complement of that would be all the elements in the space that are not even. And that's pretty much it for this section.